Hello everyone, my name is Tamash and with me today I have Hugh and Himanshu. Welcome to CloudVision Chats, a new multi-part series, or I guess we can call it a podcast, where we'll discuss all things CloudVision, tips and tricks, best practices, common misconceptions, and all the fun stuff. So let's get started. Today we are going to have a brief intro into CloudVision, and then we are going to talk about the differences between traditional polling and real-time state streaming. And then we'll have a demo about CloudVision dashboards and how you can use it to monitor your network. So with that said, Hugh, would you like to do the honors and briefly describe what CloudVision is?
Okay, thanks, Thomas. So, what is CloudVision? Well, simply put, it's Arista's provisioning and management platform that allows you to know what's going on in the network, build new elements in the network, and identify and fix issues all in real time. The cornerstone of this ability is the real-time streaming telemetry sourced from Arista's EOS devices. This provides real-time data about the working of the network and the health of the devices. This data can be in the form of real-time metrics, updates, events, and flow information. Having collected this data, there is a lot we can do with it. With CloudVision, we can display it in real time on dashboards. We can also provide time-based correlation data to extrapolate and avoid future issues. Using machine learning, we can also identify anomalies in the network that might otherwise be missed by thresholds-based alerting. This gathered information can be applied to many use cases. For example, CloudVision can discover and track endpoints and workloads to provide policy input into Arista's multi-domain segmentation services, or MSS for short. We'll have more on this in later chats. CloudVision provides a consistent set of features and functions across all network domains. As with EOS, Arista has strived to provide a single management and monitoring platform for all areas of the network. Integral to CloudVision, there are a set of domain-specific services, such as Pathfinder for enterprise traffic management. These features enhance CloudVision's capabilities in the domain by building on the foundations created with the stream telemetry infrastructure. Monitoring and managing a network involves understanding what risks the business is exposed to. This risk can come from badly maintained software and configuration. CloudVision addresses these issues for the network by providing a set of software and configuration and audit and compliance services. These services come in the form of compliance views, providing real-time analysis of software and configuration life cycles, and also compliance events, as well as real-time bug and CV exposure views. Change management has been part of CloudVision from the beginning. Using change control workflows and templates, along with the ability to quickly roll back changes should they not go as planned, has led to improved uptimes and more successful changes and upgrades. Combined with custom actions and snapshots, CloudVision provides a significant automation workflow, all in the same platform. Expanding on automated provisioning, CloudVision provides the ability to zero-touch provision EOS devices across the network as soon as they are delivered. CloudVision can even be integrated into a wider enterprise solution such as Ansible, providing a single integration point and a set of APIs for all EOS devices. There's so much more to CloudVision, but these 8 categories provide a good idea of what's available to help any network operations increase network-wide visibility, simplify day-to-day tasks, secure networks, track all changes, and reduce the overall cost and time to deliver network solutions.
Thanks, Hugh. That was great. There's certainly a lot of topics we could cover in future chats. Not only is CloudVision a comprehensive monitoring platform, but it provides a wealth of provisioning and automation features that all help our customers to build and monitor high-performance stable networks. So in today's episode, we're going to focus on real-time state streaming, a bit of history about that, and a quick demo if the demo gods allow it. Um, so without further ado, I get started, and I'll ask the first question to Himanshu, which will be, how do we get the state information from the network devices themselves?
Hey, Thomas. So let me just quickly start with probably a protocol that is way older than me, I guess. So we have had SNMP around forever. It's the good old reliable classic way to monitor network devices. Now with SNMP, you're basically having a polling-based approach where you typically would have a network monitoring system wherein you feed the SNMP MIPS, and using OIDs, it reaches out to devices at set intervals, requesting specific data using OIDs. Now, in many cases, this works just fine. But here's one of the challenges. Polling only gives you a snapshot at the moment of the poll. And the frequency of these snapshots is determined by the polling interval. So for example, if you have an NMS which is polling every minute, you're only seeing the state of the device once per minute. So imagine if you're monitoring interface rates and there is a sudden spike in the traffic, like a microburst. If that surge happens between your polling intervals, you're most likely to miss it entirely. And that's just about missing a singular event, because in networks, you typically have multiple events which can happen simultaneously.
So what happens when a series of rapid state changes occur between polling cycles? Do you know if these happened all at once, or were they gradual? Did they coordinate with some other change occurring at the same time in the network?
So that's a very interesting point about one of the challenges with a polling-based approach like SNMP. When rapid changes happen between polling cycles, we tend to have no real visibility into how they occurred, whether they are happening over a period of time or they happen instantaneously. And another thing is about correlation. So imagine monitoring CPU utilization and you see it jump from 10 to 90% between two polling cycles. Did that spike happen instantaneously, or was it correlated with a configuration or network change, which caused some network churn or maybe a spike in the broadcast traffic? A lot of these challenges get exponentially worse when more and more devices are added to the polling cycle, or basically you're reducing your polling cycle, and now more stats are being pulled. And that also not just increases the load of the network monitoring system, but it also increases the bandwidth over management network, because you remember SNMP is poll-based approach. So you send a GET request or a walk, and then you get a response back.
And how do we tackle this in CloudVision then? Do we use SNMP to collect the metrics at all?
All right, so I guess now's the time I get to say welcome to the dark side of the force, Thomas. Um, Instead of relying on traditional SNMP polling, CloudVision takes a different approach, one that leverages the unique architecture of EOS. So if you are familiar with Arista devices, each of the Arista device runs our operating system called as EOS. And within EOS, we maintain a local database called SSDB, which contains the exact point in time copy of the entire system. That not just includes your protocols, BGP, OSPF, but also all the process states and all the different variables like power and cooling. Now, each of these state which is maintained in all of these devices can be streamed in real time to CloudVision, which can be stored in an aggregate network-wide database. And this aggregated data not just gives us a pinpoint view of the network device state at that particular point in time, but also gives you a network-wide view. And this helps you to correlate network changes or events which are happening across your network.
So that's a lot of data. So where do we store all of this data?
Yeah, that's a lot of data to store. So all of this is streamed, which is from each of these switches through CloudVision. You basically store this high resolution data into something called as a distributed time series database within CloudVision. Now, this not just allows you to record and keep a point in time copy of that data, but also allows you to travel into the network-wide state at any point in time. So whether you're troubleshooting an issue which is happening in real time, or whether you're investigating an issue which happened in the past, you can easily go back to a point in time and see exactly what was happening on one particular device or in your entire network at that moment. And because you have this data from multiple devices, in fact, your entire network over a period of time, it also helps you to do correlations and also analyze trends within that data. So you could say that, okay, I have a memory issue, which is memory, which is growing on a particular device. So I can predict and say, hey, take a look at this device.
And what technology or protocol do we use here? Do we follow a pull or a push model? And what about the traffic? Do we encrypt it?
Yep. So for real-time data streaming, unlike SNMP, which uses a pole-based model, we use a built-in streaming agent on the switch now, which comes packaged with EOS itself. So all you have to do is just configure it, and it leverages gRPC, an open-source remote procedural framework developed by Google. Now, gRPC runs over HTTP2 and HTTP3, making it highly efficient for streaming telemetry data. Now, for example, with this, you also have data compression, meaning you can compress the data when you're sending over your management network, thereby reducing the overall bandwidth. And instead of traditional pull-like model, we use a dial-out push model, meaning you don't have to reach out to the device to say, hey, can you tell me what are the interface status right now? As soon as an event happens on the switch, it is streamed to CloudVision in real time. So say, for example, you learned a MAC address or a route gets removed, that information is instantaneously streamed to CloudVision. And yes, security is always a priority. So the traffic is fully encrypted using TLS 1.2 or 1.3, meaning if there is anybody sniffing packets using Wireshark, they'll not be able to see what data you're streaming.
Okay, come on. PCAP or it didn't happen. Is this something that's visible in TCP or Wireshark?
So I knew you were going to ask that, and I think it's the network equivalent of pictures of didn't happen. So let me switch over and show you a quick Wireshark capture, which I have, capturing the telemetry data between the switch and one of the three-node cluster to which I am streaming. And you can see here I have a switch which is streaming to a three-node CloudVision instance, CVP 0, 1, 2, and 3. And all you can see is that the entire application data is encrypted using TLS 1.2. So this means that if anybody is taking a packet capture setting in between, they won't be able to see what information that you're streaming to the CloudVision instances.
So essentially, that means we use a subscription model and stream changes as they change, but we also have the possibility to set a sample interval for noisy telemetry. Now, I guess before getting to our demo, if someone would like to understand more about CloudVision, where can they read documentation from? And we've recently launched our new CloudVision Help Center that replaces the old config guide that has been around for ages. This exists both in product and also on our external website, as Himanshu is showing. And you can read the docs there on per on-prem version basis or also for CVAS. We love Help Center and it's highly recommended. It can save you a lot of time and you can also give feedback about it using the feedback button in the product. I'll let you start the demo.
All right, so I think with that, maybe we can just take a look at some of the dashboards that we have built. So within CloudVision, you can see all the device state that is being streaming on a per device basis. So you have all these graphs. For example, here I have AIV3, all the process, CPU, and memory utilization. But you can also do something called as dashboards. Now, with dashboards, it's really taking the best of CloudVision. You can build multiple panels and aggregate data from multiple devices or multiple sources. So this is a very nice dashboard which was built by Tamash for this demo. And let me quickly walk through what all information we have out here. So on the first row, we have some of the aggregate panels, which show you interface status related metrics like the administrative state, operational state, the software version. We also have a very nice compliance panel, which shows me bug exposure or compliance with respect to configuration, image, or software and hardware end of life. If we move down, we have a nice aggregation of interface status panels, which shows us events related to these interfaces. And clicking on those panels, you can see those respective events, again, which we will come to when we are talking about our demo. You also have a very nice time blocks panel. So over a period of time, if there were any events of different severity, the color coding will change from green to red or warning based on the severity of those events. If we come down further, we also have very nice horizon graphs and some tables which show us data related to interface rates, discards, and Lanzi metrics in real time as they are being streamed in a traditional graph-like manner. So again, this is something that we'll see once we are talking about a demo. A very quick overview about Lanzi, if you're not already aware. It basically tracks the interface congestions and queuing latency, providing real-time reporting. You can view this information on the switch itself, or you can stream it to CloudVision, which we are doing out here, and view it in very nice panels that we have here.
So these dashboard panels, are they available natively in CloudVision, or do you have to make them yourself?
Oh yeah, so all these amazing widgets are available natively, and you can just click on edit and add these panels whichever you want. And based on the metrics that you're wishing to add, you can create these panels and aggregate the data. Obviously, there are also ways in which you can create your own panels and query the data within CloudVision using something called as AQL. We'll have some links down in the description.
Do you have something also on the SNMP side that you can show us?
Oh, yes, sure, Thomas. So obviously the comparison won't be good if you don't have something on the SNMP side. So again, I just put something together using the Grafana and device that I have where I'm polling MIBs with the same devices that I have in CloudVision. And again, this is using just the plain old SNMP MIBs that we have. So you just get the inventory table here, which shows you the hardware and software information, some metrics related to memory and CPU, interface table, and yeah, the same information that we saw in CloudVision, the packets in, packets out, and the discards.
All right, let's see if we can generate some congestion. So hopefully the demo gods are with us. And we should see it in a few seconds.
Yes, so I think you started the traffic, and I can immediately see a spike in the transmit latency and LANZ graphs. I can also see some LANZ queue drops. And yeah, there you go. We are starting to see discards on 8021/1 on AI Leaf 3. So in real time, this information is being streamed and we can see discards are happening on this particular interface. Let me quickly switch over on the SNMP side as well, just to see what information I have available here. So, okay, so unicast packets in, I do see the graphs, and unicast packets out. Yes, I am see a spike in the graph there. Let's talk about discards. So 21/1, let us see. Okay, so there is no change in the graph from the previous value. I think we're just waiting on for the next polling cycle. All right, but I don't have any metrics here related to LANZ, so I think that's one of the things that I'm missing out on the SNMP side. If we head back over to the CloudVision tab, so yep, we can see the graphs are still updating, and I still don't have any updates on the, oh, there you go. So I think SNMP took some time to kick in based on the next polling cycle. So yeah, that's one of the real-time examples that you can see of EOS state streaming architecture versus the poll-based system of SNMP. So I had to wait for the next polling cycle to kick in for me to be able to see the discards which are happening. But on CloudVision, I was able to see it immediately as soon as they happen.
And I guess we won't be able to see the spikes because I've been turning on and off again the traffic on Ixia, and looks like on CloudVision we can see it instantly, but we can't see anything on the SNMP side, sadly.
So let me quickly cover some of the other panels that we had talked about earlier. So yeah, you can see earlier this panel was green, and here also we have the color coding changed to red. That shows us that there are some active events which are happening. Let me click on this discards and errors, and I can see, okay, so there are two events which are reported, again, for the same Ethernet 22/1 and AIV3. So this is basically taking us to the events page where we will see more details about the event itself. Now, event is just a notification from CloudVision based on the data it is ingesting, and it is alerting the user that, hey, there is some event going on in the network. Now, this event is not necessarily you have to sit on the CloudVision UI and see. You can also forward these events to different platforms like email, Slack, and Google Chats.
That's really cool. I noticed that on some of the events there were more than one event more than one alert showing up. Is there a reason for that?
Yep. So I think the reason why we were seeing that was we had some of the events which are a group event. So let me actually go back to the page where we had our interface congestion discards. Yeah. So for example, in this particular event, which we have the interface congestion discards, it is basically a group event that is triggered by the events that we are seeing here below. So there are three triggering events which basically triggered this group event. If you go into the individual event itself, you can see that it will tell you that, okay, this event was the one which triggered the group event. So group event basically captures all the events related to congestion discards which are happening on the switch so that it helps you to correlate and avoid having a large clutter of events on the UI page. Okay, and if we scroll down, we can see all the details with respect to this particular event. So for example, the event related to interface TX discards will have graphs related to PFC, POS frames in, the TX discards, the TX traffic rate, and the queue drops that we were talking about earlier.
So why do some of these interface graphs have different shades of the same color?
So that's a nice observation, Thomas, which brings us to how we are able to fit so many different metric graphs in such a nice and compact way, while also making sure we are able to interpret them correctly. So for example, if you see the utilization out graph or even the unicast packet graphs have different shades of blue. The reason for that is basically it is to illustrate different values. So let's say we have three segments for each color. And each segment has like 10 points. So if you have a range from 0 to 30, you can divide it into 0 to 10, 10 to 20, and 20 to 30. And if you have a bit rate value which falls between the 0 to 10 over a period of time, the graph will be filled with a lighter shade of blue. As soon as the packet count increases and you kind of go over to a bit rate of, say, 15, the graph will be filled with a lighter blue entirely. And then we'll start to fill it again with a darker shade of blue from bottom to top. And if you have a bit rate of, say, 25, which is falling in the third category, then it will be filled with a lighter shade of blue, again, a darker shade of rendering on top of that, and eventually you'll have a much more darker shade of blue in the middle. So in order to understand it, think of it as stacked graphs. So I have a small diagram here which I can help to make sense. So you see here, in our case, we had three different traffic rates, 20 Mbps, 30 Mbps, and 45 Mbps. Typically on CloudVision, you will see it something like this. And this is the different shades of blue that I was talking to you about. So for a lighter blue, you'll have 20 Mbps. If you kind of expand that, it'll look something like this. A 30 Mbps is basically a stacked on top of that with a darker shade. So in order to save that space on the UI, we are basically the horizon graph is showing you like this, and same goes for the 45 Mbps. So yeah, these are the different shades of blue that you see. Even for the utilization, you can see we have different color codings here, which are indicating different values. Now you can always click into this particular metric in order to see a much more traditional graph, which would have the timeline on the bottom and obviously the values, which will be on the vertical axis.
So can we dig into this data for any of these metrics that we see? I mean, is there more you can see on this?
Yeah, so you also have a lot of information available here. So for example, one of the features that I like is the data table. Now, click on the data table gives you a tabular form of that data. And it also gives you a timestamp when that particular value was recorded. So in this case, it gives you these timestamps and the values in a tabular format. You can always export this to CSV. So in case if you want them to export to a spreadsheet and do some analysis of your own. You also have data paths and statistics. Data paths just show you where that data is being sourced from. You also have related metrics. So in this case, for example, when we are talking about utilization, the related metrics would be the bit rate and the packets in and out. This changes depending upon the metric that you're viewing. So for example, if I switch to memory-related metric like memory usage, and I check the related metrics, I would see all the metrics that are related to the memory utilization.
Very cool. Thanks, Hugh and Himanshu. I think we've learned today the differences between polling via SNMP and streaming data through gRPC, and we saw some of the monitoring and network observability capabilities of CloudVision. And while SNMP has been super helpful and a key part for decades in many networks, modern networks require a more robust and scalable solution for collecting and analyzing the data from the fabric. We hope you've enjoyed this episode where we may play around with the format. This is kind of what we were thinking about, and feedback, of course, is more than welcome. So please comment down below. In the next episode, we'll do a deeper dive into various dashboard capabilities of CloudVision, and then in later episodes, we'll also going to go through our query languages. With that, thank you all, and see you next time.